Ahoy Captain, and welcome to this first version of the tool tutorial for the battery hybrid single engine tool. It's a mouthful, but it is quite an interesting and complicated topic. This video is intended for members and those who have bought the Excel or the tool itself in order to get them started. We're going to do it in two parts. The first part will be the web tool online version, and the second part will be the Excel itself, where you can tweak, save and customize settings. Feel free to skip to the parts that you like, otherwise enjoy the movie. Before we start, a few disclaimers first, so let us click and go through it. First of all, the tool itself is an estimate, not a detailed design or engineering. It's supposed to be a techno-economic feasibility for hybridization of your auxiliary engine with diesel. Quite a lot of assumptions. It is very much customizable, but it remains an estimate. So if you need more information or want to dive deeper into the topic, contact us or any of our suppliers. Secondly, it is not based on a ship type specifically, so please be wary, especially when it comes to EU ETS or fuel EU, that it applies to your business case. And thirdly, it is subject to change quite a lot at this point in time. As a matter of fact, we will be changing it continuously and hopefully update it along the way. Mostly that will be in the way the logic of the battery itself is charged and discharged, but also the time settings right now, and I'll show you that later. We only measure once every 5 or 10 minutes, if I'm not mistaken. We want to upgrade that time to get you better estimates on the technical and also economical aspects. That being said, there's one way for us to handle all the uncertainty, and that is the help desk itself. So at any time, if you are experiencing a writer block or need some help, feel free to contact the help desk to make your life easier. We're here for you, so make sure that you use us as well. So without further ado, let's dive into the first part and see how the web tool works. And here we are. This is the member page. As you can see, it's still under development. We're actually recording the video, but if you scroll down, you see the battery hybrid single engine tool. So we start with the engine power. The standard is 90 kilowatts, but for the purposes of this video, we're going to do 95. Average engine load, auxiliary engine load, while in harbor, is standard 20%. I'm going to change that to 18, and you'll see that, well, first we're going to change it to 50. Then you see that the average power demand also changes. We're going to leave it at 18 again. First rule of advice: if you are above 50% engine load, then usually depending on your engine settings and also of course cost of the fuel, but mostly maintenance cost, economically speaking, it won't always be beneficial. You need I'll show it later. Cliffhanger. And then finally, the amount of running hours you want the battery pack to have. Well, we'll just leave it at 8 hours. We can always change it later. Then we can press let's go, and you can immediately see the business case with the key results. So that's the central part. First, normally we go through the technical specs, but we always want to know what the end result is, so that's where the business case happens. And then finally we can save scenario either in the report or in this version of the tool itself. So we're gonna go from left to right, but know that if you input the values you just now saw, then this is the end result. The technical specs. Here we see the battery hybrid power demand, and we set 8 hours. So after 8 hours of running, the engine kicks in because the battery is empty. Here you see the battery being drained. At the lower state of charge, the generator kicks in, powers both the onboard facilities, the hotel load, and also recharges the battery. When the battery is full, then again, the whole story again starts anew. We want to make sure that the battery is roughly equal at the end of the day. Well, we do now for an entire day as where it started. We're still working on making the best consumption, but we're assuming the battery needs to be charged fully again with the engine running, so the auxiliary engine. So we want to have it at the same maximum state of charge at the end of the measuring point as where we started. We also here have the conventional running of the engine. So we see here the let's see, conventional auxiliary engine at 18 kilowatts, and now we also have the hybrid power demand, which is slightly lower. And that's going to the right hand side here, parasitic loads. What we assume is that there is a part of the engine power demand that's being taken by, for example, fuel pumps, fans, maybe heaters for the fuel, probably not with diesel, but there usually is a certain amount of parasitic load when running an engine. And that's the reduction that we have from working electrically versus conventionally. But we also have to account for any electrical losses. So these two are discounted. It also depends on the system. Normally I just say keep it at 15% or 5%. And in this case there is a slight benefit for running it electrically. If we change the amount of running hours, you see that the battery capacity itself is also affected. It needs to be bigger, but the engine hours in total and efficiency gains, those are mostly dependent on the average power demand at engine, as we'll see later. So if we go back to hybrid, here you can see that the amount of time running on the generator will be increased or decreased depending on the amount of running hours that you have. Now here at engine, here we see engine load. If we change that, for example, to 15, then we also see that the average engine hours and SFC will change. And again, a resulting average power demand here. All the calculations are very much dependent on the specific fuel curve. And as you can see here, we have an optimum at around 222 grams per kilowatt hour for this auxiliary engine, but we can manually either decrease the curve and make it more efficient, or we can increase the curve and make it less efficient, the engine. So we're just going to leave it roughly at 0. And very important, the engine maintenance, the amount of euros per hours to run the engine. That's especially important when it comes to the OPEX. Here the battery itself, we have the same picture, but if we go, we can change the maximum state of charge, and we can change the low state of charge, after which that will definitely impact, of course, your amount of running hours. So if we maybe decrease the amount of running hours, and then here we go. So it automatically, all the calculations lead to a certain amount of battery pack, and with a battery cell price we have an estimate of the Capex. That can be done in the business case later, but here you can also already tweak a bit the estimated price, which is mostly dependent on your battery cell price. So if we change this to 400, yeah, you can see that it is very much, for the most part, dependent on a battery cell price. So here you can dimension your battery and whatever you want. Technical drawings, these are under development. We want to give you some basic technical drawings, but these have not been finished yet. And then finally, the total amount of emissions for the conventional, the hybrid case, with the emission factors, grams per gram for fuel, and then the amount of emissions saved. As you can see here in this case, pretty much all the emissions saved are the CO2s respectively per day, which are about 380 kilograms per day. And then finally we have an overview of the conventional versus the hybrid physical properties here, so you can check the amount of fuel consumed. Again, it's a little bit more extra as opposed to the things that you see on top, but also the OPEX estimates. And here you see this already makes quite a lot of difference running it conventionally versus hybrid, but most of it has to do with saving engine hours. And that's also why, going back to engine, this is so important, because the engine hours saved here, that's usually where most of the savings come from in these situations, unless you have your engine running at a very low load. Then you also see quite some significant fuel savings. That's it for the technical aspects. Going back to the business case, as you can see, everything here customized according to what we filled in. Fuel price, but also very important, is port call. So we do days. A port call is basically the day that you just now saw. So what we're gonna do is we're gonna, for example, increase it to 185. Then you can see more benefit because we use the system more often. So if we do this for a full year, if we more the ship every day, then you can see that this already becomes quite beneficial. But I'd say that's not very that's not what we want to do, so let's keep it at 180. These are all the results, summarized results, and if we go to customize, you can see the most important aspects to change, especially battery capacity, an important one. But we can also add design, refit and class, and then you see that the Capex is significantly increased. There you go, so almost 175,000. That makes a big difference on your business case. We can also lease equipment to see if we can lower the maximum exposure here. So if we go back to not adding the design, refit and class, if we go to lease equipment, yeah, here you see that, okay, then maybe your payback rate might be delayed in this case for about a year. Your maximum exposure is almost reduced by half, and also you in this case with leasing you pay a little bit more compared to your base case, quite something more, but it could be something that that's interesting, especially if you can have some sort of a very low interest loan or maybe multiple years. If we can increase the lease period here, then we can get a pretty low risk case. So that's could be something to discuss with the supplier of the system itself. And here the Capex we see in this case, of course, most of it is because of the equipment, but it's almost always the case. Class and certification we have seen is quite expensive for these types of refits, and here you go. In this case it's become, it wouldn't be very attractive thing to do. I'm gonna remove that one again, because we definitely want to give a positive business case, at least in the tutorial. You can always change these prices here, so discuss also with the supplier in the end if you truly need all these types of equipment listed. This is something we're currently investigating, what you need, what you don't need, depending on what you provide in the technical aspects. The resulting OPEX with savings, so in this case we have a loss because we pay more in lease or rental, but we save on fuel, maintenance and everything else, so we can compare these values and have a nice differential in terms of percentages. So we still have a 30% savings overall. And then the most important aspects here, we see that UHS doesn't really matter that much, does it? No, slightly it does. Fuel, more sensitive to fuel. Engine highly sensitive to engine maintenance, so check that one out. Spares and consumables, also highly quite sensitive. I'm gonna check to see if that is also correct. Because this seems to be very sensitive. Well, it is a lot per hour, but still. As you can see, the model itself, it works, but we're checking if everything is linked correctly. So more on that later. Subsidies will be made available soon. And then finally we can save scenario. So if you enter your email here, you can get a price indication, or we're gonna allow you to save this scenario. Simply save it and you get a link and you can reuse it later. So let us know what you would like to have, and we'll make it work. So still a work in progress, but let's now go to the download Excel. And I've just now made the download Excel button available. So if you click on it, you should get, there we go, the Excel sheet downloading itself. So let me open it. There we go, lovely. We're still working on the instructions. As you can see, disclaimer and everything else still needs to be properly updated. And basically these are the instructions, so I'm not gonna bore you with that. We have an overview, or we have technical input, business case input, and everything in one clear overview, or at least the most important parts. We have the battery hybrid system. I'm gonna zoom out, and this is basically a detailed information. This is the more detailed information of the entire battery system, with also specifications for the battery, switchboard, Capex, OPEX, detailed Capex breakdown, and a yearly cash flow. Power profiles, a very important one. Here you can see how we actually build the model itself. So this is probably the most important one to check. A fuel EU comparison for the conventional and the hybrid case that we calculate. This can be almost a separate tool in and of itself. We already made 3 fuel EU tools, so absolutely the case. Fuel and emissions, you could technically choose for another fuel. We've added here for your pleasure and convenience, but to be honest, I'm not sure how it would work with different kinds of fuel. So we're sticking with MDO or MGO, should be the same, roughly the same. Don't ask ISO 2082-17, but yeah, do it at your own leisure. And then finally SFC here, you see the curve, SFC curve that we are using, and the resulting curve with a customized correction on the curve itself. So you can see that for the curve we take a base mark and then add the manual override, and here you get some more information on where we get our references from. Those references will be added here as well in the future. So going back to overview, how this worked, you saw just now in the web tool itself. So I'm gonna briefly go through it because most of the calculations are done in battery hybrid and power profiles. But we have our engine power, aux power, engine load, more idle, more load percentage of the engine. So everything in gray we can use as input value. We get an average power as a result, the amount of time we want it to run, and the battery capacity as a resulting a result of what we input here. Engine name, that's for, I don't know if you want to save it for some scenarios. MDO, parasitic loads, electric losses, SFC is also stated here, and the states of charges here. You can see that we have these included at the back, but I'll remove it because that should not be necessary here. Then amount of time per year that the vessel is moored and everything else for the business case. Here we have the operators for adding, design, refit and leasing the equipment, whether or not Fuel EU is applicable. So simply change that to true or false if needed. The lease rates, compliance year. This is basically only important for Fuel EU. We go, we calculate Fuel EU for a single year, 2030, and then that's roughly that's spread out over the 10 years that we calculated. It's not necessarily correct. It comes very close, but in the first 10 years, Fuel EU will not make such a big difference, and we will extend upon it in the future. And then finally, inflation and net present value discount rate here. So these are all the values that you just now saw. Then I'm gonna go to power profiles first, because that's a very important one to know what we do here. So we start off with two idle moored power profiles. We have the current and the future hybrid profile. So here we see this is simply idle moored power all the way up until the end of the day. And then we also have the hybrid power profile where the parasitic load is subtracted and the electrical losses are added. And what we basically do for each time of day, we have in the beginning a filled battery, 95% state of charge, and the generator, here let me hide this for you real quick. Generator load, that's the maximum load that the generator will provide, and this is one of the most important cells in the entire Excel sheet. And this one's even longer, but basically what we do is we have a logic that checks if the state of charge of the battery is not too high or too low. Does the generator need to be on? We've added peak shaving as a specific, how do you call it for a battery? A specific way of functioning for a battery, but right now we're doing spinning reserve only, so we're going to also make this formula easier. But what we see is that basically we check whether or not the generator needs to be on, based mostly on the minimum and maximum state of charge. But also here, this formula that we see here is a check to make sure that we see if there's still enough time left in the day to fully charge the battery again, and if not, then we need to, and if we are close to that end of the day, we need to turn on the generator in order to get back at the state of charge in the beginning. That's the most difficult aspect here. You can remove it if you don't want that to be added, but then you get sort of a free energy from a filled battery and you're not filled at the end of the day, potentially not filled. So this is the most important formula to have a look at, and this is of course done all the way until the end of the day. So then the generator power, that's the amount of power the generator will provide, a certain amount of specific fuel consumption, or of course the energy needed, the fuel needed in order to provide that energy, the amount of fuel needed, and then there is a part going the amount, this is a lot, generator energy provided, that's the amount of kilowatt hours in this time frame that's provided by the generator, and a part of it goes to the battery, and a part of it goes, of course, and the part of the battery that goes, the part of the energy that goes to the battery is of course the part that is left over after providing it to the future idle mode profile. So we are now number checking this specific formula. I have, I wouldn't say my doubts, it is fairly correct. I've tested this actually with a real battery hybrid setup, and we came pretty close, but we want to make sure that it's also checked and verified. And then finally the maximum power. Here we check the maximum power for both the hybrid and future profiles, average power profile energy required all in all over the day, which is simply the average multiplied by 24, the amount of time the engine is running, and then resulting fuel consumption here. This is an important one to understand, and what's furthermore important here in battery hybrid, we take all the most important parameters from the power profiles, and we also determine with the help of the auxiliary emission factors and the power profiles the emissions, and then using similar formulas, mostly power profile when it comes to fuel and electricity, or for example maintenance cost. Here we see that we calculate simply by multiplying these numbers coming from power profiles with a certain number that we have inputted, engine maintenance cost per hour for example, and those are shown here in overview. These can be changed if needed, and they mostly lead to a change in the Capex breakdown. These numbers will also be very much scrutinized, especially refit complexity. We'll have a look at it to see what's correct and what not, and what you need in the battery pack itself, especially in terms of the cells, the converter, transformer, and the harmonic filters. So this is definitely something to discuss with your supplier when you get a budget quote. And then finally, here we see for each year we add the different cash flows, and if needed the cash flows for leasing, which means you have a principal and pay an interest and have a payment every year, probably more. And also please note that we have inflation included here. You can set it to 0 if you want to exclude it, and also for the net present value we do something similar. If you have the Boolean of the net present value on, we simply discount each year to get you your net present value with the totals summed here. These are the most tricky parts here. There should be quite some good explanation on how we calculate all the different electrical parameters. I wouldn't say they are standard, but we have listed here how they are calculated, or what we assumed. This yellow part here, these are the maintenance costs for the hybrid system, which can also quite heavily impact your case. So have a look at these as well, especially when you talk to the supplier. And finally, fuel EU, I want to refer to our other tools and tool tutorials that we have made, in which we explain all the calculations, and the fuel and emissions tab, well, and also the SFC, we have explained that before. So it's quite complicated, quite complicated stuff. The power profiles is mostly where the magic happens, that we were gonna have verified, and then the rest of it is mostly multiplications and additions of what you see here in these in this OPEX table. And well, that's it. Hopefully this brings you closer to getting a good and viable business case, and always feel free to contact the help desk to make your life easier. We'll continue to improve this particular tool to get you something more to your satisfaction, or maybe I shouldn't be so hard on ourselves or myself, but I definitely want to give you something more, because battery hybrid systems are truly really cool, have been on top of my mind since a long time, and I'm just happy that we're finally being able to give you these tools. Contact the help desk to make your life easier, and I hope to speak to you soon, and if not, have a great day.